Hello guys, welcome back to my channel. In today's video, we will be working through another example problem regarding the design of actually loaded column. So the problem is design an actually loaded short-tied columns to support an axial dead load D of 135 keeps an axial live load L of 175 keeps. So here, initially assume that 2% longitudinal steel is desired, and we are given the 4,000 psi strength of concrete and 60,000 psi strength of steel. So the keyword here, guys, in this problem is actually loaded short-tied columns. So short columns means it is not a long columns, or moment is zero. But actually it's not totally zero. Maybe there's a small moment, but can be neglected because the eccentricity is less than to 0.1. It's very small. So we expect the columns is purely compression because it is actually loaded column. So first of all, we need to determine the applied loads. So we have only dead load and live load. So the formula is 1.2 dead load, 135 kips, plus 1.6 live load, 175 kips. The total is 442 kips. So that is our total applied factored load. Now we have to determine the dimension of the columns. Given the condition of 2% longitudinal steel is desired, and the applied factored loads of 442. So actually the solution is very straightforward. We have only this equation based on the ACI equation 22.4 2.1a. We can find this formula here. Actually, this formula is very easy to remember because we have only 0.85 FC prime, that is always the stress of the concrete, times the net area of the concrete, the net area of the concrete. So we have the gross area less the area occupied by the steel. So that is for concrete. And we have to add the compression of steel reinforcing bars, which is Fy times the area of steel. So using these parameters, we have 2% of the gross area, that is the required 2% of the steel, longitudinal steel. And for tied column, we used P 0.65 times 0.8. We have to multiply 0.8 all of these close parentheses. Then, if we substitute these parameters to that equation, we will have 442 Pu time equal to 0.65 times 0.8, and we have to multiply all these parentheses. We have only unknown, which is gross area of the column. So if we calculate the area of the columns, we have 187.6. So we choose 14 inches by 14 inches, which give us the actual area of 196 square inch. So we have this one here, 14 by 48. We have the profile of the columns. So by substituting the actual area of the columns, 14 inches by 14 inches, and the actual area of steel to this equation, area of concrete to this equation, then we will get the actual area of the required area of steel, 3.28 square inch. So let's say we use number 7 bars, the actual area is 3.61. So a little bit higher from the calculation of this equation here. Now, the next one is to determine the maximum and minimum requirements of reinforcement according to ACI section 10.6 and 0.1. This is the maximum and minimum requirements. So we will check the reinforcement with our maximum with our limitation for minimum and maximum. Then the actual ratio of reinforcement is 3.61, which is this one here, divided by the area of the columns, 14 by 14. So we'll have 0.0184, which is greater than the minimum reinforcement, and that is less than also the maximum reinforcement. So we are within the range of this limitation, so we are okay. The next one is to determine the spacing of our ties. So we have the, let's say we are using a single ties, and we have uh, criteria for that, for the spacing. So we have 48 times the tie diameter. So if we use number 3 ties, so 38, that is 38. So 48 times 38 is equal to 18. And the second one is bar, 16 times bar diameter. So we are using number 7 bars, so 7, 8, and that will give us 14 inches. The third one is less dimension of the columns, which is 14 inches. So the governing spacing is number 14, which is less compared to 18. So number 3 ties at 14 inches on center. But some other engineers at the site, they are using 12 inches, which is very common spacing, or uh, 8 inches. So it depends on the engineering judgment for column spacing there, because some companies, they have their own standard of spacing, although the requirements is 14 inches. As per calculation, sometimes they use 12. So that's all, guys, for the solution of our problem. So this the our requirements. Number 3 ties, 14 inches on centers, using the number 6 numbers, using number 7 bars, 6 number 7 bars. So that's all, guys. If you found this video helpful, please don't forget to like and subscribe. And if you have any comments or clarification, please comments down below. So thank you for watching, and see you next time. Bye bye.